Okay, I'm back and I'm here to help you with another problem from the 8.1 homework set. So this is a different one from your homework, and again, I'm kind enough to help you with your homework, so hopefully it will work out for you. And so here we have a photon. This is the wavelength, because I know it's wavelength because it's in micrometers, and that unit goes with wavelength. And so I want to know how much energy there is. So ultimately I need to, if we look at our two equations, if I want to know energy, that's going to be E equals h times nu, right? But I don't have the frequency, which is what nu is. I have the wavelength. So the first thing I'm going to need is I'm going to use C equals uh, lambda times nu, right? So I can't solve for E directly, but I can solve for nu first using the wave equation, and then I can ultimately solve for the energy of the photon. So let's start using our wave equation. So if I want to solve for nu, nu equals c over lambda. Now remember, c is a constant, right? So that's 3.00 times 10 to the 8th meters per second. And lambda, now here we have a problem, right? Because lambda needs to be in meters here. I have the wavelength in micrometers, so I'm going to have to do a conversion first. So I'll do it really quickly up here. Hopefully you all remember your metric conversions, right? So we do a little dimensional analysis here, right? So 2.36 times 10 to the third micrometers, and we multiply this times, remember, how many micrometers are there in a meter? It's 10 to the minus 6 meters in 1 micrometer. I'm sorry, it's hard to see. Micrometers cancels. And when we multiply this out, we end up getting 2.36 times 10 to the minus third meters. Hopefully that makes sense. And if it doesn't, you got big problems and you need to come see me or review. Okay? So now I'm going to plug in the value of the wavelength in meters now. So 2.36 times 10 to the minus third meters. Notice how meters cancels, which is good, leaving us with 1 over seconds, which is the unit we want for frequency, right? So when we solve for nu, let me plug in my numbers. 3 times 10 to the 8th divided by 2.36 times 10 to the negative third. And when we put that together, we get 1.30 times 10 to the 11th cycles per second. So I'll use hertz here to make it easier. So hertz. So that way you don't confuse the 1 with the exponent. Remember, we can express frequency in either hertz or 1 over seconds or seconds to the minus 1. Now that I have nu, I can go ahead and I can solve for the energy of the photon. So now I'm going to use E equals hv. We know h is Planck's constant, so 6.626 times 10 to the minus 34th. Put that in parentheses to make it easier to see. And then nu is 1.30 times 10 to the 11th seconds to the minus 1, or 1 over seconds. Remember that Planck's constant, I didn't plug it in here, but it's in joule times seconds. So 1 over seconds and seconds cancels, leaving us with joules. And then we can multiply our numbers together. So 6.626 times 10 to the negative 34th times 1.30 times 10 to the 11th. We multiply that out, we get 8.61 times 10 to the negative 23rd joules. And there's your answer. Okay. Hopefully this will be helpful for you guys, and good luck on the rest of the homework, guys. See you tomorrow.